Let's now consider the proof of this theorem. If x and y are real numbers, then the absolute value of x times y equals absolute value of x times absolute value of y. Before I start writing up the proof, I just want to make a few general observations before I start writing this up. Remember that the absolute value of x is defined to be equal to x if x is greater than or equal to 0, and negative x if x is less than 0. And this looks like a negative number, but the assumption is that x itself is negative, so negative number makes positive. For example, the absolute value of negative 5 is negative 5, which is plus 5. Now, as a rule of thumb for doing proofs, if you have a theorem involving absolute values, it often breaks up into 2 or even 3 parts. So we could have as many as x is greater than 0, x equals 0, and x is less than 0. So this could be as many as 3 parts. And this one involves absolute value of x and also absolute value of y. So there's 3 cases for x, and there's also 3 cases for y. And so hypothetically, this could be done in as many as 9 cases, where x and y are both positive, x and y are both negative, x is negative, y is positive, y is negative, x is positive, and then one or the other or both are 0. Okay, now that's certainly a way to do this, to have a proof by cases with 9 parts. What I'm going to do is slightly simpler, and it's going to be a proof by cases with 6 parts. So case 1 is going to be that x is greater than 0 and y is greater than 0. Case 2 will be that x is less than 0 and y is greater than 0. Case 3 will be x is greater than 0 and y is less than 0. Case 4 is going to be that they're both negative. Case 5 is going to be that x equals 0, so somewhere on the y-axis. And then case 6 is going to be that y equals 0, and we're somewhere on the x-axis. And that kind of visually describes how we're going to break up the cases of x and y. Now you'll notice that case 5 and case 6 contain a point in common, and that is perfectly okay for writing a proof. As long as all cases are handled, it's all right if one case is handled in two separate cases. Okay, so proof. We divide the proof into cases. Divide the proof into 6 cases. And let's list out the cases we just said. X is greater than 0 and y is greater than 0. 2, x is less than 0, y is greater than 0. 3, that x is greater than 0 and y is less than 0. 4, x is less than 0 and y is less than 0. 5, x equals 0. 6, y equals 0. So those are the 6 cases. Case 1. Suppose that x is greater than 0 and y is greater than 0. Therefore, by definition of absolute value of x is equal to x, and also absolute value of y is equal to y. They're both positive, and so the absolute value of each of them is just itself. Also, x times y is positive. If I have a positive times a positive, that's positive. And so that means that the absolute value of x times y is also itself. So this x is the same as absolute value of x. This y is the same as absolute value of y. So substituting, we find that absolute value of x times y is equal to absolute value of x times absolute value of y. So that's case 1. Case 2. Suppose that x is less than 0 and y is greater than 0. Then by definition of absolute value of x is negative x. X is negative, and so negative x is positive. And absolute value of y is equal to y. Also, if x is negative and y is positive, then the product x times y is negative. And so that means that absolute value of x times y is going to be negative itself. This product is negative, and so the absolute value of a negative number is negative the negative number. And we can write this as x times, sorry, let's write it like this, as negative x times y. Substituting, we find that absolute value of x times y equals negative x, we just got done saying is absolute value of x, y is absolute value of y, and we're done. Okay, 2 down, 4 to go. Case 3. Suppose that x is greater than 0 and y is less than 0. Now this is going to look very much like case 2, except the x and y are flipped. Therefore, absolute value of x is x, because x is positive. And also absolute value of y is negative y. Y is negative, and so negative y is positive. Also, if you take a positive and negative and multiply them, the product is negative. And so absolute value of x times y is equal to negative itself. And let's write it this time as x times negative y. Substituting, we find that absolute value of x times y is equal to absolute value of x times absolute value of y, because x is absolute value of x, negative y is absolute value of y. Case 4, suppose they're both negative. Suppose that x is less than 0 and y is less than 0. Therefore, absolute value of x is equal to negative x, and absolute value of y is equal to negative y. X and y are both negative. That makes negative x positive, and negative y is positive. Also, if I take a negative times a negative, the product is positive. And so, the absolute value of this positive number is going to be itself. Now we can write this as negative x times negative y, because negative times negative makes positive. So substituting, we find that absolute value of x times y is equal to absolute value of x times absolute value of y. Case 5. Suppose that x equals 0. Then absolute value of x is equal to 0. And so the absolute value of x times the absolute value of y is going to be 0 times the absolute value of y, which is 0 no matter what y is. Also, x times y is going to equal 0 times y, which equals 0 no matter what y is. And so the absolute value of x times y is going to be equal to absolute value of 0, which is 0. So the absolute value of x times y is equal to 0. Absolute value of x times absolute value of y is equal to 0. And so by the transitive property, so substituting, we find that absolute value of x times y is equal to absolute value of x times absolute value of y. Okay, case 6. Suppose that y equals 0. Then absolute value of y is 0. And so no matter what absolute value of x is, when I multiply it by absolute value of y, I will get absolute value of x times 0, which is 0. Also, x times y is going to be x times 0, which is 0 no matter what x is. And so the absolute value of x times y is going to be equal to the absolute value of 0, which is 0. So this product is 0, that's equal to 0, and so substituting, we again find that abscissa value of x times y is equal to the abscissa value of x times abscissa value of y. So, in conclusion, to finish the proof, summarizing, in all 6 cases, we find that abscissa value of x times y is equal to abscissa value of x times abscissa value of y. That's true for all 6 cases, and so the 6 cases cover everything, and so that is the end of the proof. So the thing that made this one hard is that there were 6 cases. Most proof by cases aren't this complicated, but fortunately each case wasn't all that difficult. It was just being very careful with the positives and negatives and occasionally zeros.